So let's see this question today. The question is nearly sorted. It states that given an array ARR which each element is at most k positions away from its correct position in the sorted order, and the value of k is given here and ARR array is given. So we have to actually sort this array, but here we have not to use any sorting method, which is directly sort array.begin or array.end. Do not have to use that. So let me explain this question. Okay, so if ARR is 2 3 1 4, okay, and our value of k is 2. So if this array will be sorted, then it will be 1 2 3 4, 0 1 2 3. These are the indexes of these elements in the array. So let's see. In the sorted array, the 1 is at 0th position, but in the given array the 1 is at second position. So there is at most k value difference. So it's for every element. If the element is 4, so the 4 is at right position, it means it is 0 value away from it. And if the element is 1, no, if the element is 2, 2 is it at 1 and here it at 0. So it's the condition is true. So we have to sort this array. Get the concept of min heap. I hope you all know what is the min heap. So min heap is, we can create the min heap using priority queue like this. It is the standard. It is given in STL, so we have to use that format: priority queue int, comma, vector of int, comma, greater of int, and this is the priority queue PQ. It is min heap. So what it does, if we insert the element in min heap, if we insert any element in the min heap, like if I'm inserting 2 3 and 1, it automatically arranges the element so that we get the minimum element after popping it. So if we pop from this min heap, so we will always get 1. So since 1 is the minimum element, this is the concept of min heap. So we have to use this concept and solve this question. So let me erase it. Okay, how can we solve this question using this? I'm telling you. So if this is our min heap PQ. Okay, this is our given array. Okay, we have to insert. I'm writing the steps here. Insert k plus 1 elements to min heap. We have to insert first k plus 1 elements to the min heap. So let's start to insert 2 3 1. It automatically arranges like this, that we after popping I will get the minimum element. Okay, keep it here. Now we have to start inserting from k plus 1 elements to end. Okay, so in this process we have to first make the size k plus 1 always. We will pop from here, but after popping we must have to insert the new element here, so that size always becomes k plus 1. Okay, so let's try run this. In this, if we pop the on popping from this PQ, we will be getting the one outside. Okay, since this one is the minimum element, so we will get this outside. So we get this outside 1. Okay, so after popping this, we have to add a new element from this. So we have to add 4th. We have to add 4. Okay, so we have to add 4. So now since min heap has the property of automatically heapifying itself, so it will reverse its order and gets the minimum element first. Okay, so now popping from this 2. But since you can observe that we don't have any element remaining in the ARR, okay, so we are not further, so we have to stop this process here. So it's our third step. Now empty the PQ. So now we have to empty the PQ, just like this priority queue. We have 3 and 4 remaining in the priority queue, so now we have to make it empty and add it to the answer array, or whatever the question says. So after inputting, we have to pop 3, so we will add 3 here. After popping 4, we have to pop 4. So this is our required answer. Okay, so these are the 3 steps here. So and what we do first, we have to initialize the size of this array. Okay, now what was the first step? First step was to add first k plus 1 elements in PQ. Okay, so we forgot to make the PQ first, so we have to create a minimum heap first. Create a min heap. Okay, so So we have now created our priority queue. Now add the first k plus 1 element. So for int I equal to 0, I is less than k plus 1 and I plus plus. We have to push this element in the pq. So pq dot push array of I. Okay, it's quite simple here. Now what's our second step? Now start pushing k plus 1 elements. Now start pushing k plus 1 elements. Okay. And also one thing more. Since the question is returning void, so we have to modify this array in place. Okay, like we don't have to create any new array, and we can see the expected complexity. Auxiliary, we don't have to create any extra array of answer and all, so we have to modify in place. So we are taking an index named initialized to 0. Now we are having our for loop for int I equal to k plus 1, since we have to push from k plus 1 to the end, and I less than n, and I is, and what's the condition? Okay, I less than n and I plus plus. Okay, there is a common mistake in all of us, like here in this condition, if the value of k is more than the number of elements, so it can crash. So we have to add one condition more, I is less than n and I is less than k plus 1. So it's now correct. And now here, firstly we have to pop from this which we have inserted the k element first. Okay, so first is equal to pq dot top. Since the top element returns the minimum value, so at the 0th index we will get the minimum value, which is correct. Okay, which is correct. And now we will pq dot pop, and we have to update the index. Okay, now we have to update. Now we have to push the element from the array of I. Like we have already popped the element, so to maintain the size k plus 1, we have also to push the element there. Okay, this loop will run till I is equal to n. So at last we will check if pq is empty or not. If not empty, so we will empty it and add all the remaining elements to the array. Okay, so while it's not pq dot empty, so we are already having the index updated, so we will start from that index, array of index. In that index we will push the top of the pq dot top, and always don't forget to update the index. Okay, don't forget to update the index. Okay, so I think this is the code, so let us run this. So here we are getting some segmentation fault occurs when there is a in loop. Okay, we are not popping the element after inserting to the index, so we have to also do pop operation here. So now we are going to run this. So it's compiled and we have to submit this. So it's not submitted. Okay, so let us discuss the time complexity of this. So since the space complexity is of k, because we are using a priority queue of k elements. Okay, so it's O of k. No, we are running this loop k plus 1 times, so O of k plus 1, and we are also doing this operations n times, so it is nlog k. Okay, nlog k. Our complexity is nlog k. So I hope you all understood this. So let's go further. Okay.